Okay, hello, welcome everyone. I want to welcome you all to this Bacon and Eggheads breakfast. My name's Natalie Goto, and I am a member of the committee responsible for selecting our eggheads and taking place, standing in for the chair who would normally be here and unfortunately has been hit with a rather nasty bug, so you're going to have to settle for me this morning. Bonjour et bienvenue à Petit Déjeuner à Papineau.
Welcome to Bacon and Eggheads. Today we have interpretation services.
Je vous avais besoin de participer
If you would like to listen to the discussions in English or French, please get yourself some headsets.
And before we continue, I'd like to pause to acknowledge that we hold today's session on traditional and unceded territory of the Algonquin Anishinaabe peoples. We acknowledge them as we travel on the journey of reconciliation. All right. For those who are joining us for the first time, PAGSI, which is organizing this, is a nonprofit organization representing 20 national organizations and academic societies in science and engineering. Formed in June 1995, our mandate is to educate and inform federal parliamentarians, decision makers, and other leaders about the importance of Canadian research and innovation. Through this speaker series, we bring researchers to speak to decision makers on a range of topics. Today's topic is wildfires. As wildfires continue to grow in duration and severity across Canada, understanding fire dynamics is critical to help us craft new approaches to address and mitigate fire impacts. Our speaker today, Dr. Jill Harvey, is a Tier 2 Canada Research Chair in Fire Ecology and an Assistant Professor in Thompson Rivers University's Department of Natural Resource Science in Kamloops, British Columbia. Her primary interest research include fire impacts on forest and natural ecosystems and forest management in the context of wildfire resistance. So after Dr. Harvey's remarks, we'll have a moderated question and answer period, and priority will be given to parliamentarians and members of media, as they may need to leave for pressing commitments. And so I'd like you all to join me in welcoming Dr. Harvey for this talk. Thank you very much.
Thank you so much. Good morning, everyone. I'd like to thank everyone involved, the committee, for inviting me to come this morning. It's wonderful to be here. I'm very happy to be here, to be able to talk about wildfire, to be able to talk about my research and share with you a little bit more about the work that we do to try and advance our understanding of wildfire science and management, and some of the projects that I work together with graduate students on. I'd like to begin just by acknowledging all the communities, the groups, the bands that I work with on the traditional and often unceded territories of the different First Nations people that I get to work with, the Ktunaxa, the Secwepemc, the Tsilhqot'in, the Inkalpamuk, the Newhawk, and the Dakhel. All throughout British Columbia, these communities are represented in this research, and the work that I do and the projects that I start are prioritized really with community interests at heart. Working together with Indigenous communities to lead and co-lead research projects is one of the things that I take the most pride in. Oh, go back. Oh. We're almost there. They warned me it was a little bit testy. It's a sneak preview. Okay, we're back. Hopefully we stay at this picture here. What I wanted to show with this picture here is thinking about forests in Canada. Everyone here identifies with forests. You know, it's part of our national pride, really, when we think about how we identify as Canadians, at least for most folks. You identify with the forests, beautiful landscapes, natural landscapes that we have in Canada. 3.7 million square kilometers of Canada is covered by different forests. Over 40% of Canada is covered by forests, which represents about 9% of the world's forests. And 90% of these forests are actually owned by governments, provincial governments, and federal governments throughout Canada. And you can see the forests there marked there in different green colors across the country. Today in my presentation, I'm really going to focus on British Columbia. That's where I've come from and a lot of my research is focused on. So we'll head over to the west coast, or the western part of our nation. Like I said, a lot of our national identity, our pride associated with these natural landscapes are incredibly important to us. You know, when we look across these vast landscapes, we can see beautiful, beautiful vistas. We can see landscapes that have got, you know, animals that are running through them. It provides important habitat. But when I look at these landscapes, in some cases, I see a tremendous amount of fuel. I see a tremendous amount of risk, potential hazard for Canadians and for communities. And so when I think about forests, and when you think about forests, you start to think more and more about wildfire. Towards the end of my presentation today, I'm going to talk about our current situation that we face here in Canada in terms of wildfire. But before I get to that, I want to share with you a little bit about the research, a little bit about the work that I do with my graduate students together. Wildfire is incredibly important for us to spend our time and our resources on. And so today in my presentation, I'm going to talk about 3 questions when we talk about research. And the first question is really, what was fire like in the past? And then there's 2 more questions that follow this. And so when I think about what wildfires are like in the past, I wonder sometimes to myself, you know, how useful is this? When we think about the future of what we face in terms of Canada for climate change, the future of climatic drying that we experience, warmer temperatures, you have to wonder if those historical analogs, what we're able to look and glean from the past, are really relevant to what we face in terms of the future. But the past often provides a benchmark. It provides us something to contextualize what we face now and what we can also face into the future. So I think looking into the past is incredibly actually important. This is the Churn Creek Protected Area. I'm not pushing the button, but it seems to be dancing around. Okay. So this is the Churn Creek Protected Area here in British Columbia, Canada. Beautiful grasslands. Anybody that's been to this area will be aware of the fact that in these landscapes, we have the largest tracts of native grasslands in British Columbia, incredibly important from an ecology perspective. These are some of the most biodiverse ecosystems that we actually can find sometimes in the world. Grasslands are incredibly important from a habitat and an ecology perspective. And these landscapes, let's see if it works. There we go. These landscapes are dotted by trees that look like this. Now, if you haven't ventured into the wilds of interior British Columbia and into these dry montane forests, maybe you haven't seen trees that look like this. This is a Douglas fir tree. It's probably 400 to 500 years old, and it's been scarred by repeated fires. This tree has stood on the landscape for 400 to 500 years old and survived fire for that long. Each of the fires that came through and touched this tree didn't kill it. These fires were of low severity, but high frequency. These fires would have cleared out forest ecosystems, they would have reduced fuels, but they left a mark on the tree. You know, just inside the bark of the tree, there's a little part of living tissue called the phloem, the vascular cambium inside the tree. And that's really what's responsible for transporting water and nutrients throughout the tree. And if it gets hurt or gets heated by wildfire, that little part of that tissue can burn. And as a result, we can mark those fires actually in the records of the tree rings. You can see these vertical lobes going up and down on the tree. Hopefully everyone can see that, marked there by the pen. Each one of these vertical lobes is a different fire event that we can actually sample. And you can see here we've taken a cross-section out from the tree. And we can sand this up and polish this, and we can use this to be able to understand a little bit more about wildfire. Here we have frequent fire. You can see here the tree rings are holding this record of fire. This tree started its life, or its most inner ring is 1604, over 400 years ago. And then fires have occurred after that, every 15 to 20 years, 12 different fire events over approximately 300 years, and then ending in 1896. 1896 is actually a really important year in the West Chilcotin and the Caribou parts of British Columbia. We see wildfires actually occurred during that year all throughout those areas, also in 1869 and other years as well. But you see the absence of these fire events after 1896. What we can see here between the fires of 1620 and 1896 is a record of landscape stewardship. The Secwepemc Highland people of Dog Creek and Canoe Creek Nation know and have shared that they used fire on these landscapes. They used fire to promote berry crops. Fire was used to clear out forests, to encourage ungulates to come in so that they could hunt them. Fire was used to mitigate wildfire risk around communities, around settlement areas. So wildfire was used effectively to manage resilient forests across these landscapes for, at least according to this tree, for 300 years, and according to the communities that have shared this information with us. 1896, no fire after that. Fire practices were banned. It was criminalized to burn after this point, and so we can actually see a record of settlers, of colonialism held within this tree. I sampled this tree in a closed canopy forest, surrounded by tiny trees, choking out the light, incredible competition for the forest, and it had changed dramatically within the last 100 years. This little blue dot here is that location in British Columbia, the Churn Creek Protected Area, and we've developed these fire histories for elsewhere throughout the province. And we've been able to create these long fire history records, sometimes dating back almost 1,000 years for certain parts of the province. And it shows very clearly that fire has been a part of these landscapes in these dry interior forests for a very long time. The second question I want to share with you today, and the work that we're doing, is looking at how are forests recovering from wildfire. You know, when I arrived in Kamloops 4 years ago and joined Thompson Rivers University, one of the main concerns that came out from communities, that came out from the university as well, was, okay, we have a lot of really big wildfires that are happening, and what can we do, or what can we understand from how forests are recovering following these wildfires? So after these wildfires are affecting our landscapes, burning very large areas and sometimes forests that haven't experienced a wildfire for a long time, how are forests going to recover following these wildfires? Are there different management strategies that we can take to try and promote resilience in these forests? And then in some cases, some of these landscapes that have burned not just once, they've burned 2 or 3 times over the last 30 to 50 years. What does that mean for these forests? Here we have an undergraduate student that's staring south down into the Beaver Valley. This is Glacier National Park. So anybody that's driven from Revelstoke to Golden or Revelstoke to Calgary, you've driven through the Rocky Mountains, the Purcell Mountains, this area, and you've seen some of these landscapes, and it's an incredibly beautiful landscape. These are subalpine forests, high elevation forests, but in the Beaver Valley, we're seeing huge fires, big fires that are lightning ignited fires that are occurring and burning across very large areas. Looking into the distance of this photograph, you can actually see a very large burnt area going down towards the south in Beaver Valley. And the area where Adria is standing, it burned in 1992, so about 30 years before the picture was taken. And there's vegetation that's coming back, there's trees that are coming back, but not far from where this location of where this picture was taken, about 500 meters away, there's another area that burned not just in 1992, but it also burned in 2017. And so what we see there is very little coming back. And we've spent long times spent in the field counting trees. I'm a field ecologist, and if you don't know what that means, it means that I spend a lot of time outside. This is not my natural habitat in here. My natural habitat is outside in the forest and in the mountains, counting trees and counting seedlings that are regenerating. But what I can share from you from this is that these forests are incredibly impacted by higher severity wildfires than have been experienced in the past. And we're starting to see more and more of these reburns, or these short interval wildfires. So where wildfires are occurring and burning the landscape within short succession. And the answers to these questions of how these forests are coming back following these types of wildfires, we don't know the answers to these questions. We need to spend time out there trying to understand this. And why does this matter? Well, this matters because these forests are incredibly important to us. We've already established that. And in a national park like this, visitors from around the world and from across our country come to these locations to be able to see these natural landscapes. Will these natural landscapes look the same into the future? We don't know. Are they supposed to look a different way? Perhaps when we look and face what we have to in terms of climate change. The main findings from this work really are circulating around the central concepts that less vegetation regeneration leads to lower biodiversity, lower species mixtures that we see in terms of the plant communities as well as the forest communities, and we're also just seeing less coming back overall. And this will have implications. When we think about resilience and we think about the ability of an ecosystem to withstand a disturbance like wildfire, there's a lot of different factors about that ecosystem that we have to really consider to say that it's resilient. Are there many species that are present? Has the ecosystem been able to persist for a long time? Is there buffering around that ecosystem to say that it will survive one of those types of disturbances? But as these disturbances grow in frequency and severity, we have to wonder if some of these ecosystems are going to change down the road. You know, are some of these mountain landscapes and these forests at high elevation, are the conifers going to come back, you know, with the different species mixtures? Or potentially there are going to be more deciduous trees that are coming back? And this all has major implications for the ecology and the habitat of these landscapes. And the work that we do to see what's coming back after wildfires isn't just restricted to high elevation forests. Together with the guardians of the Secwepemc Highland First Nation, we work together to monitor this. Long-term monitoring studies are incredibly important for our understanding of these types of changes to forest ecosystems. And following a major wildfire that happened in 2021 in the Churn Creek protected area, that burnt up that tree that I showed you at the beginning, that was recording 12 different wildfire events over 400 years. It's now a crispy piece of toast lying on the forest floor. It's changed. These fire regimes have changed. And in order for us to understand how this may cause implications for the grassland and the forest ecosystems, long-term monitoring is incredibly important. So here we've put in permanent plots, networks, large networks of permanent plots at this site and elsewhere throughout British Columbia for us to be able to really understand what plant species are coming back over time and what these changes might mean. And then also, are there management interventions that we can do to try and support some of these ecological communities? The next question that we ask is, how can wildfire influence habitat? I'm not a wildlife ecologist, and I don't try and pretend to be one, but as I was sitting in a meeting with the Olgacho First Nation, which have been evacuated repeatedly over the past 10 years due to wildfire, including this past summer in late August and throughout September, and I was sitting in a meeting with them about 5 years ago, and we were discussing what their research interests and concerns were, and it came down to caribou. And you know, when I'm working with communities, it's incredibly important for me to be flexible. You know, I actually am a broadly trained geographer. My PhD's in geography, and I feel like one of the things that geographers do is they think they can do a little bit about everything. And so some of the research that I do in my lab looks at the wood cells, the cellular structure of wood, and how drought affects it, right over to what are the wildfire impacts on caribou. And I work very hard to be as collaborative as I can be with other scientists. And when we ask these interdisciplinary questions that cross boundaries in terms of research and science, that's when I actually think that we can come up with solutions to support the community. So as I sat down with the Olgacho First Nation and they talked about their concerns with caribou, how the numbers are dwindling, how the habitat is falling away, how these giant wildfires are impacting their territory, we came along this question of, well, how long does it take for caribou habitat to recover following a wildfire? And I'll just precursor this by saying, one of the management strategies that they're given, this community in BC and elsewhere, is that after about 40 years following a wildfire or after forestry on the landscape, we think that that landscape is relatively recovered from a caribou perspective. And the community, walking through their land, understanding their land, and from my experience out in the West Chilcotin parts of British Columbia, really said that after 40 years, if you know those landscapes, they don't look like something a caribou might wander through. So we decided to tackle this question and try and answer, okay, how do wildfires impact habitat? And more specifically, how long does it take after a wildfire for suitable caribou habitat to return? The inset on this map, you should be able to orientate yourself with British Columbia up in the top left-hand corner there. The black outline indicates Olgacho territory, overlapping somewhat with New Hulk territory. The colors there are demarking the relative ranges of different herds of caribou, and each color there is a different caribou herd. The ones I'll point out quickly include the Charlotte Uplands. That herd is numbered at 25 individuals. The Itcha-Ilgachus, there in green, is numbered at 550 and is actually one of the few caribou herds, and we're talking about southern mountain caribou, that are actually rebounding up after time. This is a map with the same outline of Olgacho territory, but what you'll notice from this map is the wildfires. Take a look at the red color there. Those are wildfires that have all occurred within the last 25 years. That's a huge area of the Olgacho territory, which overlaps with very large portions of many of these herds of caribou. And when you compare that to fires that occurred, since we have some reliable records around 1920, you can see a tremendous increase in wildfire. So it's no surprise that this community and many others are very concerned about wildfire for caribou and for many other reasons. You know, when I went up into these landscapes, I really didn't think that I'd get to see a caribou. Has anybody seen a caribou before? A few folks have. Pretty neat. Magical animals, really. And we were up in the Itcha, the northern side of the Itcha-Ilgachus Mountains, which is a provincial park, a protected area. Special permissions to fly in there, community support as well to be able to do this work in this Olgacho-led project. To go up into this area, and where you see this bull caribou, or this caribou, is up near their calving grounds. So these wildfires are not just impacting really important winter habitat for caribou, but also the calving grounds. Now, this is a forest that burned in 1984, about 40 years ago. Does it look like a great habitat for caribou? No. So we decided to ask these questions. How long does it take from this, following a wildfire, to reach good forest habitat, good caribou forest habitat like you see this animal or individual using? In other words, can we go from, a forest that looks like this, which the elders had directed us to in the community and had indicated this was an area of good caribou habitat. You could see rubs on these old 200-year-old lodgepole pine. You could see tons of caribou droppings throughout the forest. It was an area well used by these animals. So what is the difference between a forest like this and a forest like this? You can see I get all of the really important jobs when I go out into the field with my students together. But this is a fire that burned in 1982. So we spent a lot of time going through these forests, trying to understand what the structure of the forest looked like and what it meant from a food resource perspective too for the caribou. How are the lichens coming back? Lichen and terrestrial lichen for these caribou is actually their most important food resource, especially during the winter. So we spent a lot of time out in the field collecting information. And what we were able to produce for the community, and this was one of their main hopes, that we be able to come up with an idea of how long does it take for this habitat to recover. And when we look at lichen, which is the top graph, I'll put another one on just down below, and time since fire, it takes we found an approximate around 74 years for good caribou lichen to come back, comparing it to controls that we'd identified based on caribou range use, as well as from information from the elders from the community. And when we look at the graph on the bottom there, this is looking more at total tree density or forest structure. We found that it actually takes closer to over 100 years for us to be able to get good caribou coming back. So from a land management perspective, from a perspective of supporting communities, being able to do this work on site, community-specific research, provided them with a lot of information that they can use to help better manage their landscapes. This is Williams Lake in 2017. So now we'll just transition to talking about where we are in terms of wildfire. This is a pretty scary picture. I think everybody in this room, probably everyone across Canada, has been touched by wildfire in one way or another. Whether it's indirectly by seeing smoke and evacuations on the news, maybe you've been in a place where you've been evacuated. Maybe you know someone that's been evacuated and the effects feel much more direct. It's something that we're going to have to learn to live with in the future in terms of wildfire, because we will see more wildfire on the landscape. This was a collaborative project that came out just last year in the Canadian Journal of Forest Research. And in this project, what we did is we looked at historical wildfires across British Columbia to try and contextualize what happened in 2023. 2023 was an enormous wildfire year for everyone pretty much across Canada. And we really wanted to try and understand, okay, what is the context of 2023 with the records that we have in the past? And so for British Columbia, and similar studies were done for other areas throughout Canada, we decided to look at all of these different fires. And the map that you see on the left-hand side, it shows 2023. You can see very large wildfires up in the northeastern part of British Columbia, and some very impactful wildfires elsewhere in British Columbia, mainly in West Kelowna and the Shuswap region. But when we look at that in the past and we think about 2023, B up in the top right there is basically showing the top 10 fire years that we have on record. 2023, when we think about area burned, is huge compared to the other years. And when we think about the largest wildfires that have ever occurred in the bottom right, you can see that over half of them, or when we think about the representation of half of them, occurred in 2023. This was a very significant year. 2023 overshadows a lot of other fire years because of its significance and its impacts across British Columbia and across Canada, but we can't forget about 2024 and 2025. You know, I don't like to say that we're in a new normal, because a new normal might imply that it's going to stay the same. I think our new reality of living with wildfire is that these red bars that you see on the right are going to continue to be high. There might be some relief, but we will see big fire years pretty regularly into the future. I think everybody's seen this one probably on social media or throughout the news, but this is looking at cumulative area burned. So we add it up over the fire season and see where we sit at the end of the fire season or the fire year. You can see 2023 on there. It's mind-boggling how much bigger that was across Canada, and these numbers are for the entire country. But take a look at 2024 and 2025 on that list as well. 2025, an incredibly impactful year for the people of Manitoba, Saskatchewan, Manitoba, and Ontario. Very large wildfires that have impacted these regions. Jumping back to just 2023, you know, I haven't been in wildfire science for that long. You know, I've been doing my research and my PhD program. I finished my PhD in 2017, so, you know, a solid 10 to 15 years in wildfire science. But if you'd asked me when I started if I'd ever see a map like this, I don't think I'd agree. But this is what the situation was across the country on July 12th of 2023. Wildfires right across our country, and we were just starting the thick part of our wildfire fighting season. And extreme fire weather. When we think about wildfire conditions and what's really important for a wildfire to burn, weather is one of the most, if not the most important variable. And we're starting to see wildfires that are so big that they create their own weather, their own lightning, their own pyrocumulonimbus clouds like you see here, or pyro-CBs. This was taken just near Lillooet in 2021. So incredibly impactful changes that we see along the landscape of wildfires. Wildfire suppression. In Canada, we're very good at this. In British Columbia especially, in Ontario, we've got really great resources that we dedicate to wildfire suppression. Wildfire suppression is incredibly important. These individuals, these agencies are charged with the protection of our communities, our resources, our infrastructure, and this is really, really important, and the work that they do is incredibly important. But we spend an enormous amount of money on this act. $600 to $800 million spent in British Columbia on average in the province. 2023 pushed that number much closer to $1 billion spent on wildfire suppression. This is an incredible amount of money that is very well spent to protect people and their property across the country. But when we think about what we have to face in the future, in terms of mitigating for wildfire and protecting our homes and our properties and our people, I think that we need to start to think about what we can do on the land to promote resilience and reduce some of the spending that's spent on wildfire suppression, and potentially spending more upfront to promote resilience. Fire scientists love triangles. When I teach a few courses in wildfire science at TRU, one course in particular, and I support a first-year course, but we always start out with the fire triangle. And anybody who's ever built a wildfire in a wood-burning stove or at a campfire at one of our provincial or federal campgrounds, you'll know that it takes three things to build a fire. The basic fire triangle, you need to have ignition, fuel, and oxygen. This is important. You need to have some logs or some fuel to start the fire. You need to have ample oxygen around the fire for the fire to go, and you need to have an ignition, a match, a lighter, some way of starting the fire. There's another fire triangle with fire science that we like to talk about, and it's the fire behavior triangle. And what's common between these two triangles, as you'll see, is the fuel. So when we think about what we can control in terms of wildfire, it's not the weather, it's the fuel. What can we do about controlling the fuel for wildfire? This is not an uncommon sight across British Columbia, across parts of other provinces, and quite often we see this situation close to communities. You know, it's not unreasonable for people to really love these natural landscapes, to build their homes, their cabins, their recreational properties in these areas that are dominated by, in my opinion, fuel. So we have to think about what we can move towards resilience. What are the different things that we can do? And I'm going to come back to fuel with the last point on this slide. The first point there, if you remember, I talked about going in and trying to understand how forests are recovering following wildfire. You know, how can these insights actually support forest management? With Parks Canada, together with Glacier National Park, some of the insights and resources that we're providing are helping them to guide some of their suppression activities. Are there areas where we should have enhanced suppression, or should we be just letting these fires burn? Are there areas of refugia, protected areas that are incredibly important for the regeneration of these forests? Should these be prioritized or protected while we're fighting wildfires in the park? And so some of the work that we do goes to support some of those decisions and some of the policy associated with fire management plans. How about these choked forests, incredibly dense forests surrounding Ogacho territory and elsewhere throughout the province? We were sitting in a community meeting thinking about these problems, and the director of natural resources for the community said, well, maybe we should go in and thin these forests. And I thought that was a very astute idea to try and promote some of the old growth characteristics. Can we accelerate old growth characteristics of forest ecosystems that have been impacted by wildfire by thinning them and promoting the growth of certain individual trees so that we can try and achieve that good caribou habitat sooner? Can we apply more fire to the landscape? And this is a whole nother talk, a whole nother discussion, but the application of prescribed fire is a very effective tool to mitigate for wildfire risk when applied in a good and well thought out way. Can we support more communities to burn? Traditional burning for cultural or other purposes is incredibly important. And how can agencies, universities, and different groups come together to support these communities to apply more fire? And this is definitely an area where we have to spend more time and resources. But I come back to the fuel. Can we thin more forests? When we think about forest thinning, if this is something that you're not familiar with, you've got a forest that's got a lot of trees on it, and you need to remove some of those trees. And when you think about a community, the community I come from, where I'm living in Kamloops, we have lots of neighborhoods that abut at higher elevations into areas of incredibly dense forests. In those communities, around those neighborhoods, and similar ones elsewhere, Can we go in and start thinning the trees? Can we remove fuel from the landscape? Can we take out trees? Can we remove those trees, pile them up, burn them, mitigate for fuel to protect our communities? These types of fuel treatments increase our resilience to wildfire when wildfires are coming close to communities. By having less fuel on the landscape, it gives fire management agencies more defensible space for them to be able to safely put people, put equipment to try and protect some of those communities. It's an expensive approach, being able to go in and do this type of work, but are there special areas, are there targeted areas that we can highlight and prioritize for these types of treatments? I think so. However, not everyone agrees on this topic all the time. Fire weather is a very important variable. If you have extreme fire conditions, oftentimes the fire behavior will overwhelm any kind of treatments that you've applied around communities. And so this has to be done really thoughtfully, it has to be done proactively, and we need a little bit more research to be able to understand how to do this. Recently, NRCan released, had a funding initiative called the Wildfire Resilient Futures Initiative. This was an incredibly important opportunity for wildfire scientists like myself to gain some resources, research funding, to be able to go out and try and answer this question. So this project is co-led between UBC and TRU, and it involves researchers from UBC, both campuses, Thompson Rivers University and Simon Fraser University, and UNBC, so across our province. Fire scientists are involved in this project on proactive fire management. And for this project, what we did is we gathered support from 30 different community forest and Indigenous-owned forests that were already doing treatments. They'd identified their forest types, the types of treatments that they wanted to do, and then our teams have gone in before those treatments and after those treatments. And when I say treatments, we're talking about forest thinning activities, and in some cases, forest thinning as well as prescribed fire. And our work is really to go in before and after these treatments to do a lot of very detailed measurements on fuels. And so our teams spend 4 hours, believe it or not, working one plot in the forest ecosystem to develop an incredibly detailed set of what the forest structure looks like and the fuels on the ground so that we can put that into a stack of fire behavior models. And hopefully what this study will be able to do is advance our understanding on the efficacy as well as the effectiveness of these different fuel treatments in forest types found quite clear across the province, from boreal ecosystems to montane ecosystems to coastal forests. And this has been a really important research project that we've just started in the spring of this year and will continue for the next 3 years. Almost. And one of the last points that I wanted to bring up before I share with some concluding remarks with you is this is really why I do this work, is to work with students. Working with graduate students is one of the most important parts of my job. As a Canada Research Chair, I just teach one course per year at Thompson Rivers University. The rest of the time, my time is dedicated to training, to working together with graduate students to advance their student-led projects on everything from caribou habitat to forest recovery to supporting industry on decisions on which species to plant and stocking densities to plant in a wildfire-affected area. And I've purposely shown pictures of some of these individuals in both, I guess, work attire or their academic selves, but and also their work selves. One thing that you'll notice is many of them are wildland firefighters. And this is one of the most interesting and valuable parts to the sort of the student group that we have coming together at Thompson Rivers University, is that we're really trying to bring together that knowledge of wildfire suppression and knowledge of wildfire management together with advancing our wildfire science going forward. And so the students really are some of the foundation for this. And when I think about the impact of my career or what's important to me 10, 20, 30 years down the road, it's these folks here that you see pictured here, being able to develop the skills they need to advance wildfire science and management both in British Columbia and also for Canada. So I have a few last concluding remarks for you. The ecological impacts of wildfire remain, there's a lot of uncertainty remaining around understanding those impacts. And so while research that goes into trying to understand that is incredibly important. We're going to experience more frequent and severe wildfires, which may eventually lead to landscape change down the road. And so understanding that, again, is incredibly important. One of the most important things for me is working together with communities. Community-based research is incredibly important. Not only do we center their voices through the work that we do in terms of research, but we can make sure that our research is applied. It's valuable, it's useful to different communities and different groups. Wildfire is expected to become more severe in the future, so we actually need to learn to live with wildfire. We need to learn to coexist with wildfire. This is incredibly important, and we can only really do this by advancing our understanding of wildfire science and management. Working together to mitigate fuel risk where it makes sense around communities is a place that I think that resources are well spent. So I think that the work that we're doing with the project on proactive fire management will give us a lot of insights on exactly how effective these treatments are and where they can potentially be best applied. And the last one there is that wildfire really isn't all of society problem. You know, everybody in this room, as we've talked about, has been impacted by wildfire. There's no doubt about that. And so when we think about what are the solutions that we need for the future, we need diverse perspectives. We all know that diversity underpins excellence. And so when we think about the multi-pronged approaches that are really required for us to advance wildfire solutions into the future, we really need to bring people together. So when I think about research, when I think about infrastructure and needs associated with that, it's about bringing people together to be able to find new solutions and think about new projects in different ways. So thank you, everyone.